Hello class, this is lesson 2-7 about percent error. And in today's lesson, we're looking at our everyday lives to see all sorts of ways that we make estimates all the time. For instance, you might take a test at school and afterwards you might estimate what your score was. You might listen to the weatherman and he estimates what the temperature is going to be today. Or before going to bed, you might estimate how many hours of sleep you're going to get. But obviously we might make errors in that. So let's discuss percent error. This is talking about a ratio that we will eventually write as a percent, and it is comparing two different things. In the numerator, we're going to be comparing the inaccuracy of an estimate. Okay, this is known as the amount of error. And we're going to be comparing that to, down below in the denominator, the actual amount that we have. So the amount of error, the way that we will determine that is by finding the positive difference between the estimate and the actual amount. All right, so we will just be subtracting those two values. So let's go ahead and do an example so I can show you what we're talking about. Suppose 800 people are estimated to attend the local carnival, but 1,000 actually attended. Use a bar diagram to find the percent error. So why don't we go ahead and let this bar represent the 1,000 people that actually attended. And now I'm going to divide the bar up into even sections, specifically 5 even sections, because 800 and 1,000 are both divisible by 200, and 200 times 5 gives me the 1,000. So now I'm trying to find the difference between that 800 and the 1,000. And so at the bottom, I'm going to just write out different percentages. So each of those sections would be representing 20. And if I have all 5 of them, that represents 100%. So we already saw that 800 people were estimated, which means that 200 people were on top of that actually came. And that represents 20%. So that is the error that was made, is the percent of error is 20%. So they were pretty far off actually in predicting how many people they thought were going to come to the carnival. And that's it. Let me show you another method now. A mechanic estimates that it will take him 16 hours, so I'm going to highlight that, to fix your car. But it only takes him 12 and a half hours, which is awesome that it took him less time. Find the percent error. So instead of making a bar diagram, this time we're going to make a ratio. And first what we need to find is the amount of error. And we'll find that by finding the difference between the estimate and the actual amount. So the estimate was 16 hours and the actual amount was 12.5 hours. So we're going to subtract those two values. And then we'll find that the amount of error between them was 3.5 hours. Now we're going to find the percent error, which is what we're looking for. To do that, we're going to divide the amount of error, which was 3.5. And then in the denominator, we can put the actual amount, which was 12.5. So 3.5 divided by 12.5 gives me the decimal 0.28, which I can write as 28%. So the mechanic made a 28% error in his estimate. In this example, it says a town has a population of 855 residents. While giving a tour of the town, a resident says the population is 900. Find the percent error. So this is, first off, a tiny town, but to find the error, again, we are going to subtract 2 of our values. We're going to take the estimate, which is 900, and then subtract from it the actual amount, which was 855. So 900 minus 855 gives me a difference of 45. And now with that amount of error, we can find the percent error. So if you remember, we're going to compare the amount of error to the actual amount. So 45 compared to 855. And when I divide those values, I get the decimal 0.053, which is 5.3%. So that was their percent error in estimating the population of their town. This next example says a coach estimates their boys football team will win 23 out of 25 games. So that's their prediction. After 10 games, they have already won 8. Okay? If this continues, what will the percent error be when the season is over? So this time what we're going to do is we're going to compare the estimated ratio, which is 23 out of 25, and we're going to compare that to the actual ratio so far, which is 8 out of 10. All right, and now doing so, to compare them better, I'm going to make them have the same denominator. So I can multiply the top one by 4. That gives me 92 out of 100. And the bottom fraction, I can multiply both of those by 10, which will give me 80 out of 100. And now using those values, I can find the amount of error. I'm going to go ahead and subtract their numerators. So I can subtract 92 minus 80. And when I subtract that, I get 12. So far the amount of error is 12. And now, like we've done before, let's find the percent of error. And we do this by comparing that 12 to the actual amount, which would be 80. So 12 divided by 80 gives me the decimal 0.15, which is 15% error. All right, I have one more example for you. This time it says a coach estimates that their girls' basketball team will win 9 out of their 12 games. After 3 games, they have won 2. If this continues, what will the percent error be when the season is over? So again, let's record the ratios for the estimated amount, which is 9 out of 12, and compare that to the actual amount so far, which would be 2 out of 3. To make them have the same denominator, I can multiply the bottom one by 4 to give me 8 out of 12. And now they both have a common denominator of 12. And since that's the case, I can find the amount of error by subtracting their numerators. So that would just be 9 minus 8, which would equal 1. So now we're ready to find the percent error. And to do that, one more time, remember we are going to be dividing that amount of error, which is 1, and dividing that by the actual amount of 8. And 1 divided by 8 is the decimal 0.125, which is 12.5%. Okay, so the coach wasn't too far off in their estimate, but they still made a slight error. So to wrap up, I want you to try one problem on your own about a softball team, and then come with any questions that you have in class.